Hi everyone, this is Dr. Nak and we are going to go over our practice final exam. Before we begin, I just wanted to say that I am very proud of every single one of you, and you should also be very proud of yourself for all the effort and energy you put into this class till the end. And just one more exam and you all are free to go. Anyways, so let's just get started on this. So number 1, sketch the graph of the given piecewise function. Label all relevant points. So it looks like we're given two linear functions. Let me just jot down what's going on here. If I need more grid, I'll just add it on as we go along. All right, so let's try to graph up the first function. The first function is 1/4 x minus 3 if x is less than 4. So x is 4 is right here. Okay, so it looks like this graph is going to have a y-intercept of -3. And the slope is positive 1/4, so you're going to go 1 unit above and then 4 units to the right. And I'm going to have an open circle there because x is strictly less than 4. So it looks like our first graph is going to look something like this. Pretend that's a straight line. All right, so this is going to be our y equals 1/4 x minus 3. Okay, so now let's try to graph up the second function. -2/3 x plus 3 if x is greater or equal to 4. So it looks like this one has the y-intercept of +3. And slope is -2/3, so I'm just going to go down 2 units and then over 3 units. Okay, so I'm just going to try to connect that. But the thing is, this graph is only defined from x is greater or equal to 4. So just to get the feeling of what the graph is going to look like, let me just draw it out, draw out the line, and then I'll just erase wherever I need to erase. Oh my goodness. Okay, pretend that's a straight line. Okay, so now it looks like, let me see, let me just erase what is unnecessary. So I'm just going to erase this portion here. I'm not quite sure where the graph is going to start at 4. So let me just check and see where the graph is going to start when x equals to 4. So when x equals to 4, the bottom function is going to become what? -2/3 times 4 and then plus 3. So it looks like you're going to have what? -8/3 plus 3, which is 9. So it looks like it's going to be at 1/3. So let me just erase this. And let me just put 1/3 is maybe up here. And then I'm just going to go straight down just like that. All right, so this is the graph of y equals -2/3 x and then plus 3. Okay, so that was number 1. Now let's go with number 2. Find the difference quotient. Simplify the answer all the way. Show all of your work in an organized manner. Okay, so first, as a side work, what I'll do is I'm just going to compute f of a plus h. Okay, so that's going to look like what? 2 plus 4, a plus h, and then minus 5, a plus h whole quantity squared. Okay, so this is going to be 2 plus distributing the 4, 4a plus 4h. And then be careful, you're going to have to FOIL a plus h. So here you're going to have -5 times, now if I multiply a plus h twice, you should get a squared plus 2ah plus h squared. Okay, so now just let's distribute the -5 and combine the like terms if we can. So here you're gonna have what? 2 plus 4a plus 4h minus 5a squared, and then minus 10ah minus 5h squared. Okay, so I think I'll just leave it like that. All right, now let's put this all together then. So therefore, our f of a plus h minus f of a, whole thing divided by h. So it looks like this is going to become 2 plus 4a plus 4h. Oops, I'm just going to box it like this so you don't get confused with what I'm writing. And minus 5a squared minus 10ah minus 5h squared, and then minus f of a. So be careful. That minus is going to go in front of the whole entire function f of x. So in this case, you better put a parentheses around f of a. So in this case, f of a is what? 2 plus 4a minus 5a squared. And don't forget this whole thing all over h. Okay, so now let's simplify a little bit. So looks like what we're going to get is 2 plus 4a plus 4h minus 5a squared minus 10ah minus 5h squared minus 2 minus 4a and then plus 5a squared. Whole thing, oh my goodness, all over h. Alright, so now let's see, what can we cancel? We should be able to cancel a lot of things. So we could cancel the 2's, 5a squared, and 4a, kill. And then, can we kill anything else? Nope. So let me just rewrite what we have left over. So it looks like we're going to have 4h minus 10ah, and then minus 5h squared, and then whole thing dividing by h. Now factor the h from the numerator and cancel it with the bottom h. So if I do that, what we're going to get is what? 4 minus 10a minus 5h. Okay, so that's going to be our answer. So our answer is 4 minus 10a and then minus 5h. And here it is. Okay, number 3. Find the domain of the following functions. Write the answer in interval notation. Okay, so let's go with part A. F of x equals negative x to the third over 4th root of 5 minus x. So first of all, if you're given the 4th root, whoever sits inside better be greater or equal to 0. However, in this case, notice that the 4th root is going to be on the denominator. So it cannot be 0. So with that said, combining all the informations together, the domain part is going to be, restriction will be 5 minus x better be strictly greater than 0. Okay, so now add x on both sides, then you're going to have 5 is greater than x. If you don't like it this way, rewrite it. So this is the same thing as x is less than 5. Okay, so in terms of an interval notation, if you're still iffy on writing the interval notation, just draw yourself a number line. So this is negative infinity, positive infinity. X is strictly less than 5. So open, and then you just shade over here. So it looks like our domain is going to be from negative infinity to 5, and then it's open, so make sure to put a parentheses. Okay, so that is our first answer. All right, so now let's go with part B. You got x to the 4th over 3x squared plus 5x minus 2. So it looks like we can factor out the denominator. So you got x to the 4th. And let me see. 3x and an x. And what? Maybe minus 1 plus 2. Does that work out? Let's check. Yep, it works out. Okay, so in this case, that means the restriction will be what? 3x minus 1 cannot be 0. And then x plus 2 cannot be 0. So in this case, what? X add 1 on both sides, then x cannot be positive 1/3. And then x cannot be negative 2. Okay, so let me just draw the number line, so just so that I don't mess up on writing the interval notation. So here's negative infinity, positive infinity, negative 2, and maybe 1/3. X cannot equal to negative 2 nor 1/3, so I'm going to have an open circle around it. And everything else you shade. Okay, so now translate that into the interval notation. So you're going to have negative infinity to negative 2 open. And then union, don't forget the middle part. A lot of students forget the middle part. So that's the middle part. And then union, and then 1/3 to positive infinity. Okay, so that will be the domain. All right, so now let's go with part C. F of x equals cube root of x plus 1. Now, if you're given the odd root, such as cube root, fifth root, seventh root, there shouldn't be any restriction inside of the radical. So in this case, you can plug it in any value that you want, positive x, negative x, and so forth, and f of x will still be defined. So in this case, the domain is going to be all real numbers. Okay, so in that case, an interval notation should be negative infinity to infinity. Sorry, that was a, looks like a closed bracket there. Infinity side should be always open. And here you have it. Okay, so number 4. Sketch the graph of f of x equals log base 3 of x plus 8. Find the domain, range, asymptotes, and intercept. Okay, so first thing, let's just go over the general graph here. So let me just draw this out. Hopefully you'll have enough room. Okay. So if you have y equals log base b of x, your graph is always going to look something like this. It's always going to go through 1, 0. And then your graph is going to go through like this. Okay, now at y equals to 1, this point is always going to be b comma y is 1. B is the little base that's attached on the log. Okay, so notice that in this case, your asymptote is x equals to 0, and so forth. Now, if I shift this graph to the left, let me just draw that out. So suppose I'm going to shift this graph and then, oops, we're going to shift the vertical asymptote. And let's pretend this is going to be x equals to negative c. Okay, then the graph is going to look something like this. Okay, so, oh, I hate drawing graphs. Okay, I'm so bad at this. So let me just jot down the key point here, and then maybe here. Okay, so let me just draw this out. Okay, so in blue, this is nothing but, let me just call it a g of x equals log base b of x plus c. So that means you're going to have to shift the graph c units to the left. Okay, so what's going to happen is this point here, meaning when y equals to 1, this point is always going to be b minus c comma 1, and this point on the bottom is always going to be 1 minus c comma 0. Okay, so basically what I'm trying to tell you is this. You can memorize this. So if you have the form g of x equals log base b of x plus c, what's going to happen is that your asymptote, oops, it's going to be x equals to negative c. And then your key points are going to be b minus c comma 1, and then 1 minus c comma 0. Okay, feel free to memorize this if you need to. All right, so keep that in mind and let's tackle the problem. So our function f of x is log base 3 of x plus 8. So if I follow that through, let me just write it as, okay, our f of x is log base 3 of x plus 8. Okay, so in this case, our c is going to be 8. So what we're going to get is we're going to have the asymptote. It's going to be at, what is it? X equals negative 8. And then our key points. Okay, one of them is going to be what? B minus c comma 1. Now our b is a little base, which is 3. So we're going to have 3 minus 8 comma 1. I'm running out of room. So in this case, what we're going to get is what? I don't like the way I'm writing this. Sorry. I hope you can see this. So this is negative 5 comma 1. It's going to be one of the key points. Let me just move the key points over here. Now another key point is given by what? 1 minus c comma 0. Okay, so in this case, we're going to have what? 1 minus 8 comma 0. So it looks like we're going to have negative 7 comma 0 is also going to be our key point. All right, so now I think we're good to go. So let's just graph this out. Okay, so it looks like, so let's pretend this is 1, 2, 3, 4, 5, 6, 7, 8 on the negative side. So this is our vertical asymptote, which is x equals to negative 8. And then let's jot down the key points. So key points, one of them is negative 5 comma 1. That's when the y is 1. Negative 5, where is negative 5? 1, 2, 3, 4, 5. Okay, and then another key point is negative 7 comma 0. Okay, so now all you have to do is connect those dots and draw that graph. So I'm just going to draw the graph in red. I'm going to jot down the key points. So the key points here, negative 7 comma 0, and then negative 5 comma 1. Okay, so, oh my goodness, looks like our graph's going to look like that. Okay, so that is going to be the graph of log base 3 of x plus 8. Now let's fill in the blanks. Okay, so what's going to happen now is what then? The domain is defined from what? Negative 8 through positive infinity, but your graph is never going to touch the vertical asymptote at x equals negative 8. So in this case, our domain is going to be from negative 8 open till positive infinity. Now the range is always going to be what? From negative infinity to positive infinity. When you look at the range, you look at the graph from, again, bottom upward. So that if you look at the very bottom, it's going to start from negative infinity, and this graph is going to keep going up and up and up. So the range is negative infinity to positive infinity. Now the asymptote, we already discovered that one. That's what? X equals to negative 8. All right, and then our x-intercept looks like it's going to be negative 7 comma 0. For the y-intercept, how do you find that is what? You set x equals to 0 and then you solve for y. Okay, so let me just work that over here. So you got y equals log base 3 of, you're going to set x equals to 0. So you're going to have log base 3 of 8. Okay, now I know that you have your scientific calculator with you, but your calculator does not have log base 3. It only has natural log and log base 10. So what you need to do to get an approximate value for the y, you need to use the change of base formula. So I don't know if you remember this or not. So this is same thing as log base 10 of 8 over log base 10 of 3. Okay, now if you punch that in the calculator, I got this guy to be approximately 1.9. Okay, so the y-intercept is going to be when x is 0. Our exact value for the y is log of 8 over log of 3. And this is approximately 1.9. So this point on the graph, so this is your y-intercept, is approximately 0, 1.9. Okay, so that's for that one. Okay, so let's go with number 5. Find the inverse of the function. Find the domain and range of f of x and f inverse of x in an interval notation. All right, so let's get to work. So first step is what? Interchange the role of x and y. So f of x equals to y. So what you need to do is you're going to change that to a x equals negative y over 3y minus 2. And your job is to solve for y from there. Okay, so now what I'm going to do is multiply both sides by 3y minus 2. So if I do that, I'm going to get 3y minus 2x equals negative y. Distributing the x, and I have 3xy minus 2x equals to negative y. Again, you're solving for y, so what I'm going to do is I'm going to add y to both sides, and then I'm going to add 2x on both sides. So if I do that, I'm going to have 3xy plus y equals to positive 2x. And on the next step, what I need to do is factor out the y. Okay, so I'm just going to bring it over here. So it looks like our y is going to be 2x over 3x plus 1. And that y is going to become your f inverse of x. So I'm just going to rewrite it as, therefore, f inverse of x is 2x over 3x plus 1. Okay, so what do we got? Okay, so now, let me see, let me just box that. Okay, so now let's go with the domain and the range of f and f inverse. So first, let me just draw this picture out. Okay. So this is going to be the domain, this is the range. So your f is going to go from domain to range, of course, and then f inverse is going to go the other way around. Okay, so it looks like the domain of f, that's exactly the same thing as what? The range of f inverse. Okay, and then range of f. All right, that's on the right hand side. That's exactly what? The domain of f inverse. Okay, so that's the relationship. Okay, so with that said, let's first find the domain of f of x and f inverse of x. So I'm going to work that one in blue. Okay, so we got for f of x. Okay, let's look at the function f of x. The restriction is what? 3x minus 2. The denominator cannot be 0. So that means what? Your x cannot be 2/3. Okay, so that's the domain of f of x. And then let's go with f inverse of x. All right, so let's see. The denominator is 3x plus 1. So that cannot be 0. That's a plus, sorry. So that implies that x is negative, cannot be negative 1/3. Okay, so if I need to write this out, so let's first go with the domain of f of x. So the domain of f of x in an interval notation, so the x cannot be 2/3, so it looks like we're going to have what? Negative infinity to 2/3, open, union, and then 2/3 to positive infinity. Okay, and the domain of f inverse is x cannot be negative 1/3, so in interval notation, you're going to have negative infinity to negative 1/3, union, negative 1/3 to positive infinity. Now let's go with the range of f and then range of f inverse of x. Okay, so I'm going to follow the relationship that we wrote above. So the domain of f is same thing as range of f inverse. So the domain of f is same thing as the range of f inverse. So here you're going to have negative infinity to 2/3, union 2/3 to infinity. And then range of f is same thing as domain of f inverse. So the range of f better be same thing as the domain of f inverse. So what we're going to get here is negative infinity, negative 1/3, union, negative 1/3 to infinity. There you go. Okay, number 6. Let f of x equals negative x times 3x plus 1 times 4x squared minus 12x plus 9. State the intercept, the zeros, and their multiplicity. I can never say that word right. And the end behavior. Sketch the graph of the polynomial function by hand. Label all intercept and any other relevant points. Alrighty, so let's get started on this. So first, let's factor the f of x all the way. So it looks like I could factor this into what? Negative x, 3x plus 1. And the last one, let me see. 2x, maybe 2x. And then minus minus, was it 3, does that work? 4x squared. Yep, that works. Okay, so it looks like 2x minus 3 is going to repeat itself twice. So let me just rewrite this as, let me just erase this. I'm going to use the exponents now. So you're going to have 2 up here. All right, so let's first go with the x-intercept. Okay, so the x-intercept are going to be what? You're going to have to set this whole thing equaling to 0 and then solving for x. So it looks like we're going to have 0 and then what? Negative 1/3 and then 3/2. Okay, so if I have to, since I'm going to have to graph this out, let me just jot down the ordered pairs. I'm going to have 0, 0, negative 1/3, comma 0, and then 3/2, comma 0. Those are the points that I need to plot. Now the y-intercept is setting x equals to 0, and then you just solve for y. Now if I plugged it in x equals to 0, notice that first term, negative x, it's going to become 0. 0 times anything is 0. How boring. So in this case, your y-intercept is going to be 0. So if I plot it, it's going to be at the center, 0, 0. All right, now zeros and multiplicities. Okay, so when the 0 is 0, we're going to have what? The multiplicity, 0 with multiplicity of 1. And then for negative 1/3, looks like we're going to have another multiplicity is 1. And then for 3/2, we're going to have multiplicity of 2. Okay, so what's going to happen is this. At x equals to 0 and negative 1/3, your graph is going to be a linear. It's going to mimic a linear function. So it's just going to go straight cut through. Now at x equals 3/2, multiplicity being 2, it's going to behave like a second degree polynomial. So it's going to touch the x-axis and then either it's going to go down or up from there. But anyways, we'll just deal with that in a minute. So let's first go with the end behavior. Okay, so notice that for the end behavior, if you multiply the whole thing out for f of x, notice that the degree is going to be 4, and furthermore, the leading coefficient is going to be what? Negative 12. So for the end behavior, let me just write it on the bottom. Okay, so your f of x is going to look something like negative 12 and then x to the 4th. So in this case, our graph is going to look something like this. It's going to mimic negative x to the 4th. So it's going to go down. It's going to look like a downward parabola almost. Okay, so now let's take a look. Let's analyze this a little bit more. Now notice that the degree of f of x, if you multiply it out, that's going to be 4. Now that implies what? We're going to have 3 turning points. Okay, so you might want to keep that in mind. Let me just box that in case I forget. All right, so it looks like our end behavior better be as x goes to negative infinity, f of x is going to go towards negative infinity. And then as x goes to positive infinity, our f of x is also going to go towards negative infinity. Now those of you who's going to be taking calculus, we write this as the limit. As x goes to negative infinity of f of x, this is going to go to negative infinity. And then this guy right here can't be written as the limit. As x goes to positive infinity of f of x, now this is going to go to negative infinity. All right, so let's just graph this out. One of these days my graphing skill will improve, I promise. Okay, so let me just jot down the grid. 1, 2, 3, maybe 4. Okay, I'm just going to give a little rough sketch of it. All right, so let me just jot down all the x-intercepts and y-intercept. And negative 1/3 is maybe right here, comma 0. And what else? 3/2, so it's 1.5, comma 0. And note that your end behavior is going to look something like this. It's going to have to go this way and then this way. All right, now keeping that in mind, then let's just draw this out. Now, the multiplicity is 1 at 0. So in that case, this is going to, going to go straight down, striking down, just like that. All right, and then at negative 1/3 is also the multiplicity is 1. So it's going to cut through like a linear function, just like that. All right, and then what? Since the graph's going to go from bottom up, so it looks like it's going to do this business, huh? Maybe it's going to go like this, oops, and then like this, and it's going to dip down somehow, and then that's one turning point, and then second turning point. And then at 3/2, multiplicity is 2, and the tail end of the graph has to go down on the right. So what needs to happen is what this needs to happen, like this. Like a second degree polynomial, parabola looking downwards. So let me just connect it. My lord, look at my graph. But you get the point. You get the idea. So we have what? 1, 2, 3 turning points. They're both going to go towards the tail end of the graph are going to be both going to be negative infinity. So that will be my rough sketch of the function f of x. Number 7, for the following rational function, find the domain, the intercepts if any, and the equations of the asymptotes. Write the intercept as points, and for the asymptote, indicate whether they are vertical, horizontal, or slant. Then sketch. All right, so let's stare at this function a little bit. Notice that the numerator is not going to factor out. And furthermore, the degree on the top is 2, degree on the bottom is 1. In this case, you are guaranteed to have a slant asymptote. But we will deal with that in a second. Now, let's first go with the domain. So clearly the domain is what? X cannot be 1. So you're going to have negative infinity to 1, union, and then 1 to positive infinity. Okay, now for the x-intercept, I'll put the graph at the very end. Alright, so the x-intercept, you're going to have to set y equals to 0, and then you solve for x. Now, y equals to 0, that means only the top has to go to 0. Now, since that does not factor out, what we need to do is use the quadratic formula. Okay, so let's just fill it in. So what do we get? Negative b, so it's going to be 2 plus or minus the square root of b squared is 4 minus 4 times a is 3. C, whole thing dividing by 2 times a, 6. Alright, so notice that I don't even need to compute this anymore because look, the radicand here is a negative number. And what? You got a square root of a negative number, so that implies that this whole solution is going to be imaginary. So in this case, we don't have any x-intercept. I'm going to write it as no x-int. Okay, so your graph is not going to cross the x-axis no matter what. Alright, now let's go with the y-intercept. In this case, you set x equals to 0 and then you solve for y. So if I plug it in 0 in place of x, your numerator is going to be 1. Denominator is negative 1, so y equals to negative 1. As an ordered pair, you can write this as x is 0 and then y is negative 1. Alright, so the equation of the asymptote, so for sure we're going to have the vertical asymptote at x equals to 1. Let me just put vertical. And as I mentioned earlier, we're going to have that slant asymptote. Alright, now how do you find that slant asymptote is you just divide the top by the bottom. Okay, so let me just write it out. Oops. Okay, so if you can use long divisions of a polynomial if you like, but I think in this case maybe synthetic division might be a little quicker. So I'm going to use synthetic division on this. So I'm just going to put a 1 and then 3, negative 2 and a 1. The quotient of it is going to be the slant asymptote. Keep that in mind. Alright, so let's start. Drop down to 3. 3 times 1 is 3. Add, I'm going to have 1. 1 times 1 is 1. Add, I'm going to have 2. So the remainder is 2. It looks like our asymptote is going to be y equals 3x plus 1. We don't care about the remainder. So this is going to be our slant asymptote. So let me just write it above. Okay. So now I think we are ready to graph this out. Okay, so if I need more grid, I will just add it in as we go along. Alright, so first thing, no x-intercept. And the y-intercept is 0, negative 1. So this is going to be our y-intercept. Alright, and then we're going to have a vertical asymptote at x equals to 1. Okay, now that's the vertical asymptote. So let me label everything. So x equals to 1. And the slant asymptote is what? 3x plus 1. So the y-intercept is 1. And then slope is 3. So 3 over 1. So rise 3. 1, 2, 3 over 1. So it looks like this is going to be our slant asymptote. All right, so since your graph has to go through the y-intercept, it looks like we're going to have this situation going on for the bottom part of it. Okay, now let's deal with the top. Okay, so keep in mind that your graph is not going to cross the x-axis no matter what. So most likely it's going to be in between those asymptotes, but just to check, plug it in when x equals to 2. When x equals to 2, you want to make sure that your graph is not down here. You want to make sure the graph is going to be up there. Okay, so let me just erase this. I'm going to check. Where can I check? I'll just check right here. When x equals to 2, corresponding y value is what? 3 times 2 squared minus 2 times 2 plus 1, all over 2 minus 1, which is 1. So it looks like we're going to get what? When x is 2, the top is what? Maybe 9. Okay, so 2 comma 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so your graph is going to be up here, so your graph's going to touch that point. So it looks like, oh no, I'm running out of room. It looks like, so hold on, let me extend this a little bit. Okay, our graph is going to look something like this. My gosh, can you follow my work? I hope you can see what I'm trying to do here. Okay, so that is my graph. Okay, so the next one is number 8. Given that polynomial, use the rational zero theorem to list all the possible rational zeros. So basically you need to list out all the p over q's. Okay, let me just write it out. P over q's. All right, so p is all the values that's going to divide a constant term, and then q is what's going to divide the leading coefficient. Okay, so luckily our q is plus or minus 1. Yay. So let's go with the p over q's then. So what's going to divide p would be what? Plus or minus 1. 2 is going to go in. Plus or minus 2. Plus or minus 3. Plus or minus 4. Plus or minus 6. Plus or minus 12. All right. So that's all the possible rational zeros. Now, let's go with part B. The graph of the function is given below. Find one actual rational zero. Write the zero. So hopefully you can see this graph, but clearly the graph is crossing the x-axis at x equals to 2. That's 2. And then x equaling to negative 2. All right, so keep that in mind. So those are going to be the zeros for sure. So I just said one actual rational zero, so I'm just going to write it as 0 is x equals to, doesn't matter which one you pick, but I'm feeling positive, so I'm going to put x equals to 2. So notice that that implies that f of x has a factor of x minus 2. Okay, so keep that in mind. All right, now find all the remaining complex, real or non-real zeros. Give exact answers. All right, so since f of x has a factor of x minus 2, you should able to divide the whole entire f of x by x minus 2, and the remainder should be 0. So let's get to work on that. I'm going to use the synthetic division. So I'm just going to write it as 2, and then what's our f of x? Leading coefficient on x to the fourth is 1, negative 2, negative 7, and an 8, and a 12. Okay. Okay, so drop down the 1. 1 times 2 is 2. Add 0. 0 times 2 is 0. Add, you're going to have negative 7. Negative 7 times 2 is what? Negative 14. Add 8. Negative 6. And then negative 6 times 2 better be negative 12. Remainder is 0 as we expected. So right now we got f of x equals x minus 2, and then we're gonna have x to the third minus 7x, and then minus 6. All right, so now we're gonna have to keep factoring this out, but let me just take a look at this guy right here. Okay, we need to break this down somehow. All right, now let's take a look at the other 0. Other 0 is what? X equals to negative 2. So I'm just going to write other 0. That means what? X plus 2 is also a factor of the whole entire polynomial f of x. That means what? X plus 2 should go into x to the third minus 7x minus 6. Let me just write everything out. So what I'm going to do is I'm going to take negative 2, and then we're going to divide that into x to the third minus 7x minus 6. So you got 1. And then x squared is missing, so be careful. You're going to have a placeholder of 0, and negative 7 and negative 6. All right, now let's see. Oops, drop down the 1. 1 times negative 2 is negative 2, add. And negative 2 times negative 2 is 4, and then add. And then what? I'm going to have 6, and remainder is 0. Okay, so it looks like so far we got x minus 2, and then we just got x plus 2 in there. And the rest of it is going to look like what? 1x squared, and then minus 2x, and then minus 3. We got this. We're almost done. All right, so then let's see. Can we factor the last one? I think we can. So it looks like we're going to have x minus 2, x plus 2, and you're going to have x. You're going to have 3 here, and then 1 there. Look, yay, we're done. Okay, so this is all in factored form. Let me just box that. So the remaining complex zeros, besides x equals to 2, please feel free to include 2 if you want to, but remaining complex zeros are going to be negative 2, and then what? Negative 1, and then 3. And then of course x equals to 2 was also a 0 as well. Okay, so there you have it. Number 9, solve each exponential equation. Give the exact solution. If there is no solution, write no solution and explain why. Okay, part A. 2 to the 2 minus x equals 5 to the 2x plus 5. So in this particular case, there is no way in heck that we're going to able to equate the bases. So in that case, I will compose both sides by the natural log. So I'm going to have ln of 2 to the 2 minus x equals ln of 5 to the 2x plus 5. Now use the property of the logs and bring the exponent out in the front. Okay, now please note that ln of 2 and ln of 5, those are just some kind of a numerical values. So treat them as constants. So These are some numbers. I'm going to distribute this constant to each term, also this constant to each term. Then what we're going to get is 2 times ln of 2 minus ln of 2 times dx equals 2 times ln of 5 times dx plus 5 ln of 5. So since we're solving for x, bring all the guys that has an x attached on it on one side of the equation and dump everything else on the other side of the equation. So in this case, let me just bring the 2 ln of 5 times the x to the left by subtracting it. So let me see. I'll go minus 2 ln of 5 times the x minus 2 ln of 5 times the x. Then we're gonna have what? Minus ln of 2 times the x minus 2 ln of 5 times the x. And then let me just bring the 2 ln of 2, that's just a constant, on the right hand side by subtracting it. Okay, so then what we're gonna get here is what? 5 ln of 5 and then minus 2 ln of 2. Okay, so now notice that we can factor the x out. So here you're gonna have minus ln of 2 minus 2 ln of 5 times the x equals 5 ln of 5 minus 2 ln of 2. Okay, now I think we're good to go. Solving for x, we're gonna have 5 ln of 5 minus 2 ln of 2, whole thing divided by what's in the bracket, which is minus ln of 2 minus 2 ln of 5. Okay, so leave your answer the way it is. So the solution set is, I have to copy this again, right, minus 2 ln of 2, whole thing over minus ln of 2 minus 2 ln of 5. Alright, this is solution set. Okay, I'm just going to box that. Okay, that was part A. Now let's go to part B. 4 to the 3x equals 1 over 256. Okay, so in this case, I believe that I can write 256 by using base 4. So let me just take this step by step. So this is same thing as what? 4 to the 3x equals 1 over 4 to the, what power? Is it 4th? Okay, so which implies that we're going to have 4 to the 3x equals 4 to the negative 4. So since bases are the same, we just equate the exponents. And easy as that. Solving for x, we're going to have x equals negative 4/3. So our solution set is negative 4/3. Number 10, solve each log equation. Give the exact solutions. If there is no solutions, write no solution and explain why. Okay, part A. So first step, that what you need to do is isolate the log. Okay, so solving for log. First step, I'm going to subtract 10 from both sides, and then we're going to have negative 4 ln of 9 minus 8x equals 6 minus 10, negative 4. Now solving for ln, so that means what? We need to divide it by negative 4 on both sides. Then here you're going to have 1. Alright, so now since we're solving for x, we need to kill that ln. Who's going to kill it? Is e. So we're going to e it on both sides. Raise it over e. Then what's left over is what? 9 minus 8x equals e to the first. E to the first is some kind of a numerical value, so I'm just going to treat it as a number. Now solving for x, I'm going to get what? I'm going to add 8x on both sides and then bring the e on the left, so I don't have to deal with negative values. So here you're going to have what? 8x is going to be 9 minus e. So our proposed solution, our x is 9 minus e whole thing over 8. Okay, so let me just box this, and don't get too excited yet, because when you're given the log equation, you're going to have to be careful, because let's look at the argument of the log. Argument of the log has to be strictly greater than 0 no matter what, or else your log will become undefined. So what you need to do on the next step is to, when you plug that x value in, make sure that 9 minus 8x is going to give us a positive quantity, positive values. So let's check. So 9 minus 8x, our x is 9 minus e whole thing over 8. So what, you can cancel the 8 out. Then here you're going to have 9 minus e. See what happened? I could cancel the 8 just like that. Okay, so then what do we get? 9 minus 9, and then you're going to have what? Minus e, so you're just going to have an e back. Why did I put that in black? All right, but now notice that e is a positive quantity. So we're gonna get to keep this, and our solution is going to be 9 minus e whole thing over 8. So we keep that proposed solution as a solution set. Okay, so now let's go with part B. Log of x plus 6 minus log of x equals log of 58. Again, log of 58 is a numerical value, so treat it as a constant. So first, we need to shrink this up. We need to combine that into one log. So the property of the log says what? This is going to be log, so remember this, log of, let me see, a minus log of b. This was what? Log of a over b. So we're going to use that property for that. So I'm going to have log of x plus 6 and then whole thing over x equals log of 58. Okay, so now we need to get rid of that log, since there is the invisible 10, that's going to be the base. So what you need to do is we're going to have to raise both sides over 10. So we're going to 10 it. So we're going to raise it over 10, big 10, and then big 10. So what's going to happen now is what? We're going to have x plus 6 over x equals 58. All right, so now solving for x, multiply both sides by x, and then we're going to have x plus 6 equals 58x. So that implies that we're going to have, I'm going to subtract x from both sides. 57x equals to 6. So x, so that implies that x is 6 over 57. Please reduce your answer all the way. So it looks like what? 2 over 19. Looks good. So if I plug that x equaling to 2 over 19 into the argument of log, they're all going to be positive. All the argument of the log will be positive. So we get to keep that as a solution. So the solution set is 2 over 19. Okay, number 11. A doctor prescribes 300 milligrams of a therapeutic drug. After 1 week, drug has decreased to 40 grams. Rounding to 5 significant digits, write an exponential model representing this situation. So, step 1, you need to memorize this formula. A of t equals a sub 0 e to the kt, where a sub t is the amount remaining amount, and then a sub 0 is the starting amount, and then k, in this case, it's decreasing to 40 grams, so it's the decay rate. And then t is the time. Okay, so let's just read this again. A doctor prescribes 300 milligrams of a therapeutic drug. So it looks like starting amount, which is A sub 0, is 300. After 1 week, which means what? T equals to, after 1 week, 7. After 7 days, the drug has decreased to 40 grams, which means what? The remaining drug now is 40 grams. So that will be our A of t. So step 1, what you need to do is you need to come up with that decay rate, which is denoted by K. So let's just plug all the information in. So A of t is 40. And then A sub 0 is 300. And then e to the t is 7. So you're going to have 7k. Okay. So now in order to solve for 7k, divide both sides by 300. So here you're going to have what? 40 divided by 300 equals e to the 7k. All right, and how do I solve for that? Is attack both sides by the natural log. So you're going to have ln of 4 over 30 equals ln of e to the 7k. So what do we got? Our k, so I'm running out of room here. So here what we're going to get is 7k equals to ln of 4 over 30. So k is going to be ln of 4 over 30, whole thing divided by 7. Now punch that into your calculator. Since it's a decay, your k value better be negative, or else you did something wrong. So here, if I typed it in the calculator, I got negative 0.28784. Is that 5 significant digits? 1, 2, 3, 4, 5. Yep. All right, so now we put this all together. So let me just box this value of k. So therefore, our model is going to look like A of t equals 300 e to the negative 0.28784 times the t. Don't forget that t. On the last exam, a lot of you forgot to put that t there. All right, so that is going to be our model that we're going to have to deal with for the rest of the problem. All right, so now part B, to the nearest day, what is the half-life of this substance? Okay, so you can memorize this formula if you like, but the half-life the formula for that is T equals negative ln of 2 whole thing over K. Okay, so let me just box that. Now, if I use that formula, then our half-life T is going to be negative ln of 2 whole thing over K was what? Negative 0.28784. Okay, punch that in the calculator. I got this number to be approximately 2.408, and it says to the nearest day, so in this case half-life will be just 2 days. Okay. All right, now let's go with part C. How many grams of therapeutic drug is left after 15 days? So basically, this question is asking you to find A of t when t equals 15 days, so t equals to 15. So that's what the question is asking you to find. So let's do this. So our A of t is 300 e to the negative 0.28784 times t, but t is 15. Okay, so type that in the calculator. I got this number to be approximately 3.99955. So how many grams of the therapeutic drug is left after 15 days? It's about 4 grams. Number 12, solve the following systems of linear equation by any method. Okay, so let's just stare at this for a little bit. If I add 1 and 2, I could eliminate the x. So that's what I'm going to do first. So I'm going to go 1 plus, so let's call this equation 1, 2, and a 3. Okay, so first what I'm going to do is 1 plus 2. So I'll write every step out. X minus 3y plus z equals to 4, negative x plus 2y minus 5z equals to 3. Alright, so if I add that vertically, we're going to have what? Negative y minus 4z equals to 7. Alright, so let me just box this. Alright, so now what else can we do? How about multiplying by negative 5 to the first equation and then add to that third equation. So what I'm going to do next is I'm going to multiply negative 5 to the equation 1 and I'm going to add that to equation 3. Okay, so if I multiply the top equation by negative 5, then here what I'm going to get is negative 5x and then plus 15y minus 5z, and don't forget to multiply by negative 5 on the right hand side of the equal sign. So it's going to be negative 20, and equation 3 is just like 5x minus 13y plus 13z equals to 8. So again, I could eliminate that variable x. So then here you're going to have 2y plus 8z equals to negative 12. Let me box that. Look. So now what we're going to do is we're going to stack these two together. And then I'm going to eliminate either one of the variable if I can. So let me just stack them up together. So you got negative y minus 4z equals to 7. And then I have 2y plus 8z equals to negative 12. Alright, so here is the new systems of linear equations. Now let me see, how about let's try to get rid of the y by multiplying the top equation by 2. So if I do that, let me see, if I'm going to multiply this guy by 2, let me rewrite. So then you're going to have what? Negative 2y minus what is that, 8z equals 14. The bottom is 2y plus 8z equals negative 12. Uh-oh, what's going to happen here? Now, if I add that vertically on the left-hand side of the equation, you're going to have a 0. On the right-hand side, you're going to get 2. 0 equals to 2. That could never happen. So in that case, that's a contradiction, which means that there is no solution to this problem. Meaning, no matter what kind of x and y and z you're going to plug them in, you can never have a solution to it. So, solution, so this means no solution. All that work to determine that solution is no solution. No solution notation is curly bracket with nothing in it, so this just means no solution. Alright, here you have it. Number 13, find the partial fraction decomp of that. Okay, in order to do this, make sure that you factor out the denominators completely before you start anything. But x squared plus x plus 2 cannot be factored, so I'm just going to have to attack the problem as is. Let me just write 8x squared plus 12x minus 20, whole thing over x plus 3, and then x squared plus x plus 2. Okay, now to determine how many partial fraction that you're gonna get is count the exponent on the outside of the parentheses, meaning there's an exponent of 1 and an exponent of 1 sitting there. So when you add 1 and 1, it's 2. So for sure you're gonna have 2 partial fractions. I'm gonna go boom, boom. All right, now what goes on the bottom is the first factor of x plus 3. And the second, underneath the second fraction, you're going to have x squared plus x and then plus 2. Okay, now what goes on the numerator on x plus 3 as a denominator would be the general form of the polynomial of 1 degree less than degree 1. That will just be a constant, so which I'm just going to put it as a. Now, what to put on the second fraction on the top of it is general form of the polynomial of 1 degree less than what's given in the denominator, which will be degree 2. So what's 1 degree less than degree 2? That's degree 1 polynomial. So degree 1 polynomial is going to look like bx and then plus c. Make sure to use all the different letters for all of the numerical values that are unknown. Okay, so now what we need to do is multiply the left and right hand side by the LCD, which will be x plus 3 and x squared plus x plus 2. So if you do that, what you're going to get is 8x squared plus 12x minus 20 equals a times x squared plus x plus 2, and then plus bx plus c. Be careful, make sure to put a parentheses around bx plus c. And then here what you're going to get is x plus 3. Okay, so now what I'm going to do is distribute the a's and b's and c's and then combining the like term. So here you're going to have ax squared plus ax plus 2a plus, now I need to FOIL that. So here you're going to have plus bx squared plus 3bx plus cx plus 3c. Okay, so now I'm going to combine the like terms together. So let's combine all the one with the x squared attached on it. So it looks like what we're going to get is what? A plus b and then x squared. Now let's go with the x's. X, and then this guy's x2. So it looks like what we're going to get is a plus 3b plus c times the x, and then all the constant are 2a and then 3c. So here you're going to go plus 2a and then plus 3c. Okay, so let me just keep that for now. And step 1, what I would do is this. I will first use the 0 of the denominator. You'll see why in what's going to happen in a second. So step 1, always go with the zeros of the denominator. So the zeros of the denominator is what? X equals to negative 3. And since x squared plus x plus 2 cannot be factored, so you're going to have imaginary zeros there. So we're not going to deal with that. So let's just take x equals to negative 3 and plug that in to the equation that I'm going to box right now. Here's my equation. Okay, so when I plugged it in x equals to negative 3, what we're going to get is 8 times negative 3 squared plus 12 times negative 3 minus 20 equals, alright, so if I plug negative 3, notice that bx plus c times x plus 3, that whole quantity is going to become 0, because when x is negative 3, negative 3 plus 3 will be 0. 0 times anything is 0. So all that's left over is going to be a, and then negative 3 squared plus negative 3 and then plus 2. Okay, so that way we could easily solve for a. So if I add all this together, 3 times 3, 9, and 2, so what? This is 16 equals negative 3 squared plus negative 3 plus 2, that's 8. So 8a. So that implies that our a is going to be 2. So we're able to solve for a at least by using the zeros. Now, Second step, when you run out all the zeros, equate the coefficients now. Equate the coefficient using the fact that your a value is 2. So let's equate the coefficient on x squared. Okay, so the coefficient on the x squared on the left-hand side of the equation will be 8. On the right-hand side will be a plus b. But you already know the value of a. We just determined that a is 2. So that implies that we're going to have 8 equals 2 plus b. Oh, look, now we could solve for b. So b is going to be 6. All right. Now let's equate the coefficient on x. Coefficient on the x on the left-hand side of the equation is 12. Coefficient on the x on the right-hand side is a plus 3b and then plus c. Okay, but we already know what the value of a's and b's are, so we're going to have 12 equals a is 2 plus 3 times b is 6 plus c. So that implies that we're going to have 12 equals to what? 20 plus c. So looks like our c is going to be negative 8. All right, are we done? Yes. So therefore our answer is going to be a over x plus 3. So you're going to have 2 over x plus 3. And then plus bx, what is my b is 6. And then plus c, c is minus 8. And whole thing over x squared plus x plus 2. So I believe that we just went through the whole entire practice exam. If you have any questions, again, please let me know. If I made some mistakes, please let me know. And be confident when you're going to take this final, and believe in yourself and tell yourself that I can do this, because I know that you can. So good luck on your finals. Please kick some butt.